In the earlier video of NexusMax Self-Service AI for web, machine learning model training, I created a pipeline to build a customer churn model using one of the existing auto machine learning classification model. However, in this video, I will demonstrate how to create a manual machine learning model pipeline using NexusMax AI for web. While I will have choice to choose my model and customize it as well. Further, I will also show how to deploy the model. To start with, similar to other pipelines, I will open NexusMax AI for web from browser. Then I can either create a new project or choose an existing project. Here I selected the existing retail churn project. Further, while adding a resource, I will select Manual ML Pipeline this time. I will then give a name to the pipeline, called Customer Churn Manual. On clicking the pipeline, in the next page, an empty canvas is visible. I will first arrange each phase of my pipeline by dragging and dropping required widgets and connect them all in sequence. Firstly, I will choose a resource which will be later used to train the model. For this, I will click on the source widget and click on the sources present on the ribbon to choose type of source that I want to upload. Here, I have an option to source file from Hadoop, SQL, local store, and more. For my current pipeline, I will source customer churn data from the local store. Next, from feature transformation present in the menu, I will choose AutoFE to transform the data to a usable format for model training. And for the final stage, I will click on ML Engines on the ribbon. I will then toggle to Manual tab to unhide all the manual models. And since I am building a classification model, I will choose one of the machine learning classification models. As you can see, there are various classification-related models such as decision tree, gradient boosting, and more. Here I will drag and drop k-nearest neighbors for my model training. I will now connect all the stages of my pipeline and configure each phase. Firstly, I will choose a resource for my data pipeline. Similar to AutoML, for my current pipeline, I will source customer churn data from the local store. I will then click Next to complete data configuration, and I am taken to the next stage, that is feature engineering. I will give a name called Customer Churn FE to my FE stage, and on clicking Next, NexusMax will start executing feature engineering with default parameters set in the backend. The features of this stage have already been discussed in AutoML model training. For the current demonstration, I will select Next to save the configuration of Auto Feature Engineering stage. And finally, I will get to Configure Model Training stage. For which I will first select a label from the drop-down menu, which is that feature of my historical data that I would like to predict for future customers. Next, to select partial data for my model training, I need to select type of sampling. To avoid overfitting due to lesser minority classes, I can select synthetic sample. In case if I would like to reduce or balance majority classes against minority classes, I can use reduce majority samples. For my model, I am choosing the former technique. I will then select the percentage of the data to train. Here I will choose 50% of my data. Next, to control the learning process of a model, I can customize the hyperparameters of a model. These hyperparameters are used to improve the learning of the model, and their values are set before starting the learning process of the model. NexusMax chooses a default set of hyperparameters when left with the same default tab. For Manual ML in particular, I get to choose my own parameters on clicking User Input. Here there are different hyperparameters specific to classification model. I can either check or uncheck those required. For my model, firstly, I will enter 3 in n_neighbors, that is the number of nearest neighbors to use by default, wherein the target variable will be labeled based on the highest number of neighbors from the same category among the 3 neighbors. Next, I will choose weights either uniform or distance, by which weight points are allocated by the inverse of their distance. That is, closer neighbors will have a greater influence than neighbors which are further away. Here I will choose uniform weights for my model trainings. Next are the choices provided to select the type of algorithm to compute the nearest neighbors. Here I will choose Auto. Further, I will leave the leaf size, p-values, and metric as default. And finally, I will choose for n_jobs, which is the number of parallel jobs to run while executing the model. I will then save the hyperparameters I set for my model training. Once I complete the configuration, I will click Next to save my model training stage configuration. And once again I will click Next to run the pipeline. With this, I now started executing my pipeline. NexusMax will now start building a cutting-edge machine learning model, where each phase of my pipeline will be executed in sequence. My model training is now completed in a couple of minutes, with no code experience. Further, I will get to view the performance of my model as well with metrics such as accuracy, F1 score, and more in my Results tab. I can even retrain the model by adjusting my percentage of data and hyperparameters. And there are other statistical inferences that I can make with the graphs displayed. Next, on clicking on Predict tab, I can predict the churn of the current customers using the pre-built model. For predictions, I have options to choose the file either from NexusMax platform or from my system. I will choose the data from my local store. Then all I need is to hit the Predict button. As you can see, the predictions are in progress. My predictions are now completed with a simple click. I can switch to Table tab to view the predictions. Further, I can even create a prediction pipeline where the data can be transformed prior to predictions. This has been explained in the earlier videos of AutoML model training. There is also option to predict for an individual record in the interactive prediction. All I need is to change the values of a record and hit the Predict button. You can now see I received a predicted value for a single record. Next, I will move to the deployment stage on clicking the Deploy tab. For machine learning, an MLOps environment must support a staged development and release process. In NexusMax, we support 4 stages, each of which can have separate set of resources. In the development stage of a project, as explained in the earlier videos, data can be explored and prepared, features engineered, and models trained, tested, and iterated upon. When deployed to integration stage, machine learning models can be further fine-tuned, deployed, and integrated into a line of business system. Next, I will deploy to staging stage. This stage, also called pre-production, one can do further testing to ensure production readiness of the application powered by ML. As I click on one of the stages, I will once again get to view the performance of the model. And in each of the deployed stages, I once again have various options to integrate data for predictions such as Excel, via API, Power BI, and more. And I can even interpret the data for an individual record or for the entire dataset and also add comments to the model if any. Next, on clicking Code, NexusMax can generate production-quality Python code in Jupyter notebooks to enable data scientists to review and take on as basis for further refinement. I can also integrate with line of business applications like Excel and Power BI provided out of the box in NexusMax. Docker images can also be generated and deployed into your local Docker hub, or a hub hosted on Azure, AWS, or Google Cloud Services. Further, if there are no deviations in the model, I will deploy to the final stage of production. AI projects in this environment are deployed for end customer use. As you can see, NexusMax provides a foundational MLOps environment for development and release of ML models in a disciplined manner. To summarize, I discussed how to execute a pipeline with a customized machine learning model. Further, software development has taught us that a staged development and release process is foundational to success, and a proper DevOps environment should support it. And with support of NexusMax AI services, I discussed how to deploy model to each environment of integration to production. For any further queries, you can reach us out here. Thank you for watching.